My name is Irapayam, Government College for Women, Kolar. So continuation of this video, Electrochemistry 1, paper 6. It belongs to Bangalore North University. That is session number 5. The subject is Cold-Rash law and its applications. Cold-Rash law and its applications. For that, you have to determine what is the statement or definition of Cold-Rash law and its applications. So, for outcome of this session, so every student has definition of Cold-Rash law and what are its applications. So, for this, you have to know degree of dissociation of a weak electrolyte and weak electrolyte like monochloroacetic acid. That means how weak electrolyte will dissociate it. In that, you have to find out degree of dissociation and dissociation constant. So, statement of Cold-Rash law states that at infinite dilution where dissociation or ionization is complete and all other interionic effects are absent, each ion makes a definite contribution towards the molar conductance of electrolyte solution irrespective of the nature of its ions. So, other way of defining another definition of Cold-Rash law is the molar conductance at infinite dilution of any electrolyte is the sum of the ionic conductance of cation and anion. I will once again repeat this definition. The molar conductance at infinite dilution of any electrolyte is the sum of the ionic conductance of cation and anion. So, example for this, lambda infinity of KCl is equal to lambda infinity of K plus lambda infinity of Cl minus. That means ionic molar conductance of KCl is equal to the sum of the ionic conductance of K plus and ionic conductance of Cl minus. In this application of Cold-Rash law, so this Cold-Rash law can be used. First one is it is used to determine the molar conductance of a weak electrolyte at infinite dilution. How do you determine the equivalent conductance at infinite dilution of a weak electrolyte like acetic acid? It cannot be determined by direct methods. By means of Cold-Rash law, equivalent conductivity at infinite dilution of acetic acid can be calculated. That he has taken for example, lambda infinity values of acetic acid may be calculated from experimentally determined values of lambda infinity of 3 strong electrolytes such as HCl, CH3CONA, that is sodium acetate and sodium chloride. So, in order to determine the equivalent conductance at infinite dilution of weak electrolyte like acetic acid, you have to choose 3 strong electrolytes of the ion in common of the acetic acid. The lambda infinity values of these electrolytes by appropriate addition and subtraction gives the lambda infinity values of acetic acid. So, from Cold-Rash law, lambda infinity of acetic acid is equal to lambda infinity values of HCl, lambda infinity values of sodium acetate and lambda infinity values of NaCl. You have to add these values of HCl and sodium acetate and subtract the value with NaCl. You will get lambda infinity of H plus and lambda infinity of CH3COO minus. So, by using from Cold-Rash law, so you can also calculate the equivalent conductivity of a weak base like ammonium hydroxide. Here also you have to take 3 strong electrolytes. 3 strong electrolytes are one is NaOH, another one is NH4Cl and last one is NaCl. In the similar manner, equivalent conductivity at infinite dilution of a base, weak base like ammonium hydroxide. So, here it is the values of NaOH and NH4Cl, adding and subtract this value with NaCl. we will get lambda infinity of NH4OH is equal to lambda infinity of NH4 plus and lambda infinity of OH minus ion. So for first application is using Kohlrausch law. So you can calculate the equivalent conductance at infinite dilution of a weak acid and weak base by choosing the common ion of the strong electrolyte, three strong electrolytes. That is the first application of Kohlrausch law. Second one is application of Kohlrausch law to determine the degree of dissociation of weak electrolyte at infinite dilution. So second application from Arrhenius theory. From Arrhenius theory, electrolyte dissociation, the electrolyte is completely dissociated into ions on infinite dilution. The ratio of molar conductance at concentration, that is lambda C at particular concentration, and molar conductance, that is lambda infinity at infinite dilution, be equal to the degree of dissociation. So alpha of the electrolyte. So that is, since alpha is equal to lambda C divided by lambda infinity. Lambda C is the equivalent conductance at particular concentration, can be calculated using the conductivity measurements. Lambda infinity values can be calculated using Kohlrausch law, and also possible to calculate the dissociation constant K is given by K is equal to C alpha square divided by 1 minus alpha. For example, degree of dissociation of electrolyte like monochloroacetic acid. According to the Kohlrausch law, the monochloric acetic acid ClCH2COOH is equal to the ClCH2COO minus and lambda infinity of H plus. So write this alpha is equal to lambda C, means equivalent conductance at particular concentration of monochloroacetic acid divided by equivalent conductance at infinite dilution of monochloroacetic acid. That means alpha is the degree of dissociation of weak electrolyte, can be calculated by application of Kohlrausch law. So here it is a simple ratio, alpha is equal to lambda C divided by lambda infinity. Lambda C is the equivalent conductance at particular concentration by conductivity measurements, and lambda infinity is the equivalent conductance at infinite dilution can be calculated using Kohlrausch law. Where lambda C is the equivalent conductance of electrolyte at a given concentration determined using conductivity bridge. Lambda infinity the equivalent conductivity of the electrolyte at infinite dilution is determined by Kohlrausch law. So for this you have to summarize the session number 5. So what is the statement or definition of Kohlrausch law, and using Kohlrausch law you can determine the application in the two applications. One is calculation of lambda infinity of a weak acid and weak base and degree of dissociation of a monochloroacetic acid. So for this session number 5, I will ask some questions. So first question is, the limiting molar conductance of acetic acid can be calculated. That means the equivalent conductivity or molar conductivity of acetic acid can be calculated using you have to imagine three strong electrolytes. So I have given here, it is A, B, C, 4 answers. Lambda infinity of HCl and NaCl, no, only 2, it is not possible. Lambda infinity of HCl, NaCl and sodium acetate. Third one is lambda infinity of sodium acetate and NaCl, and the D is lambda infinity of HCl and sodium acetate. From this you have to calculate acetic acid. There are three strong electrolytes, that is B is the correct answer. So HCl, NaCl and sodium acetate. Second question is, conductivity of a solution depends upon. Conductivity of a solution will depends upon the here also 4 answers are given. A is the nature of the electrolyte, B is the nature of the solvent, and C is the temperature. And D is the all the above. So conductivity of a solution depends upon all the three. So nature of the electrolyte, nature of the solvent, and temperature. So D is the answer, all the above. We'll go for third question. Kohlrausch law is applicable. Kohlrausch law is applicable. There are four answers I given. To aqueous solution of strong electrolyte, applicable to electrolyte dissolved in solvent of low polarity only. C is electrolytes at above room temperature. Last one, D is electrolyte solution at infinite dilution. So from this, Kohlrausch law is applicable for only solution at infinite dilution. That is, D is the correct answer. To electrolyte solution at infinite dilution. Number 4, molar conductance infinity at infinite dilution of sodium acetate, HCl, and are given respectively. Only any sodium acetate and HCl given values respectively. To calculate this acetic acid, the other additional value required for this equivalent conductivity at infinite dilution of a weak electron, 3 strong electrolytes. Here only 2 is given. Another one is you have to find out. There are 4 answers: infinity, lambda infinity of NaOH, lambda infinity of water, lambda infinity of KCl, lambda infinity of NaCl, lambda infinity of NaCl. The correct answer for this is lambda infinity of NaCl. So that is another strong electrode. D is the correct answer. If limiting conductivity of calcium 2 plus and Cl minus are values 119.0 and 76.0 Simon meter square per mole, then the value of molar conductivity CaCl2 will be Here there are 4 answers given. A is 195.3, B is 271.6, C is 443.3, and D is 314.3. All units is Simon meter square per mole. So for this calcium chloride is dissociated into Ca2 plus and 2Cl minus. So for this calculate this one. So we'll give the correct answer is B, that is 271.6 Simon meter square per mole. So for this session they are given following the reference books for the session number 4. So this is the end of the session 5. Thank you.